All right, now, so once we answer this question, then we're good then, because when we're talking about electrolysis of aqueous substances now, there's water in there, and therefore these ions will always be there. And so that's the story here, guys. The water is present in any compound that current is passing through. These two ions will always be formed. So let's ask another question now. And this is it. All right. What happens? And this is actually a past question, I believe. So let's we can get to that bank of questions to find out and see how they ask this question. So what happens when an electric current passes through right, and this is aqueous sodium chloride. All right. No, there are two types of aqueous sodium chloride. We can have one where we have a lot of sodium chloride in it, and in that case it's called concentrated sodium chloride, or it could be dilute, which means that it has more water than the salt. All right, so the sodium chloride, as we know, is it's the salt, household name.
All right. Chloride form separator.
Okay, let's go. Let's see. But the key word here is that it's aqueous here. So, all right. So, January, you are predicting that, well, this will separate into what? Chloride?
Yes, sir.
Chloride ions. Okay. That's interesting. Anybody else? Anybody believe January? Or agree with him? Will a chloride ion be formed?
Chlorine. Maybe I should say chlorine, sir.
Doesn't matter, same thing. The chloride ion will form, eventually turn into chlorine. So you say, but hold the answer here. Anybody else? Right.
And it probably would separate into sodium, sir.
Yeah. Oh, well, let's see. Let's see if that's the case. Nobody else have any ideas there? All right. So let's go. So aqueous. So what we're going to do here, we're going to do the aqueous part first. Aqueous now equals water. All right. And water, when current pass through water, what two ions we say are formed?
Hydroxide and hydrogen.
All right. Good. So let's divide it here. We're going to write the anion first. I'm going to write the ion one. We write the anion first, and then we're going to write the cation after. All right. Now let's put this in a box here. So aqueous means water, and then we say that anytime current pass through water, you're going to get hydroxide ions, and the cation will be the hydrogen ion. Everybody get that?
Yes, sir.
All right. Then the next thing we have is sodium chloride. All right. What's the formula for sodium chloride? So that we don't have to write out.
NaCl.
No, just sodium chloride is just NaCl. No 2 or 1 or anything in there.
Just NaCl.
But with NaCl.
No, NaCl alone. You must say a one. I script for them I cancel.
Yeah, very good. Persons here too silent. Like me have to do some I told in a class now. Alright, which is good. I mean, man, I sure say them still a lead. All right, NaCl is the answer there. So what ions would be in sodium chloride now when that separate?
Sodium and chlorine.
Sodium and chlorine. All right, so you get the Na plus here. Sorry, that's it. This anion. So
Cl minus.
Cl minus would be the anion. All right, and of course Na plus would be the cation. Usually, and that's what will happen. All right, good. So 4 ions are formed then. That's 4 ions now, no, guys. So now, this is the first part of the answer. Well, yes, these are actually formed. That's the first step. CX will most likely go on to ask you now, what substance will be deposited at the anode or at the cathode? That's the trend of these questions. So let's so the anions will go at the anode and the cations will go at the cathode. All right. If we go back to water, if they ask you at which electrode, all right, and then this part, the hydrogen ion will be, because this positive is gonna come off at the cathode. The electrode has the opposite charge to the charge of the ion. So this is minus now, is gonna go to the anode here. So hope you're understanding what's happening here with electrolysis, guys. All right, it's current passing through the substance, separating it into ions, and each ions based on the charge will go to the electrode. All right, the electrode can be the anode or the cathode. And the rule is that if it's positively charged, if the ion is positively charged, it's gonna go to the cathode. Everybody get that?
Yes, sir.
Yes, sir.
All right. So if the ion is positively charged, it goes to the cathode. If the ion is negatively charged, now it will go to the anode. All right. And yeah, and that's it. So that's what will happen here. So what we're seeing here, guys, this is a unique situation. We have a case where if current passes through aqueous sodium chloride, we get 4 types of ions. But what CX will most likely ask to know, which one will happen first? They can't happen at the same time. They can't separate at the same time. One is going to be separated before the other. All right. So which one will be separated first if we have 4? Remember that it's a case like this. The anode and the cathode is like a door, right? That can only hold one person. One person can pass through at a time. One of them maga doors some people have at home where 2 persons can pass through it at the same time. Anybody know any doors that stay like that?
Yes, sir.
Yes, good. All right. So it's the same thing. So the 2 ions them can't come out same time. So one going to get the preference. All right. And so the question is, and when I introduce it to this term, which ions will be, all right, and this word is preferential. Preferentially discharged. All right. Preferentially discharged. Which one does the cathode or the anode prefer? If 2 come there and only one can get through, one going to get the preference. All right. And so which one will be preferentially discharged? All right. So see if we can find a visual to highlight this now. Right. Preferential. This is preferential. All right, and we're looking at discharge in electrolysis. All right. And there's actually a list for that. And I want to give you the most appropriate list here. And here we go. Here we go, guys. I like this one. It's simple and easy to understand. Preferentially discharge. Hope everybody can see this one.
Yes, sir.
All right. So know this list, guys. This list is important. Going down, the arrow showing as you go down, the ones that are
Yes.
lower down would be the
Sodium and chlorine would be the quickest.
no, look again.
Oh.
Easy to discharge.
Hydroxide, I should say.
Well, all right. So if we look to this list, all right, I hope everybody is watching because everybody is silent. It says either you're doing something else or not there. Or
Hydroxide
listening.
and hydrogen.
Yeah. Well, if you're gonna say that, let's see if that's so. Anybody else agree with that? Will it be the hydroxide and hydrogen that will be discharged for aqueous sodium chloride?
Yes, sir. The bottom.
Yes, sir.
Okay, we're getting confirmation from the first female to say something in the last 20 minutes. All right, who said that a while ago? Which female was that? Hmm?
Me, sir.
Oh, you. Oh, Deborah. Oh, you sound so nice today. You just sound stronger. All right. All right, cool. Yeah, that's cool. Yeah, definitely. So we're gonna go with that. OH there and hydrogen. Why this series shows that as you go down this chart here, it gets easier to discharge. Any questions here, guys?
No, sir.
All right. So yeah, I mean that's it. It's not hard. I mean, once you know this chart here, and as a simple rule, once it's an aqueous solution, you always know the hydroxide will come off of the electrode. And once it is, yeah, I mean hydroxide always come off first if it's the aqueous solution. So anyhow, CXC set a question with aqueous solution and electrolysis and asks you what's gonna come off at the anode. Then it's going to always be hydroxide. All right, anions come off at the anode, cations come off at the cathode. So hydroxide will always come off at the anode in an aqueous solution. Everybody get that?
Yes, sir.
Mm. All right, so anode and cathode here, guys. All right, so anions there preferred in. All right, so it means now that we can go into another type of question. So CXC is not finished with you guys yet. There is more. There's definitely more. Oh, let me see it there. So let's bring up a new slide here. And what else could they ask you based on that? Let's go back to even the question and see which ions will be preferentially discharged. All right. And then maybe even change the color here and say, well, all right,
Well, sir, it would actually be common sense, yes, sir. Because the water, sir, it's the first thing.
Would it be common sense? Well, you look at it that way.
Fine, sir, because the water is a pass through and the water.
Well, you could, well, although there's more to that argument. You could also say that water requires less energy to separate than sodium chloride. So therefore, whatever ions are in the water, they will come out first. So could look at it that way, but yeah. All right, so ions will be, so which ions will be? So we said that we can say that AH plus at the cathode first. And if they ask for the reason, all right, less energy is required less current is required to separate it. All right, so that's a key here. And then of course with the and with the other one now, the OH minus now is the same. Let's just change this to minus because it's gonna be carried away there. So it's at the anode. Same reason. Less current required to liberate it, to separate it. All right, so discharge means it means that the substance is has escaped, has been separated. That's what discharge means. Right? So it's allowed to leave. So once the current pass through it and it's separate, then it can leave. All right, so that's it. And then same reason for the both of them guys. So there you go. And I've seen they asked a question about this before, and we could apply this. The other step further to this though, guys, is let me even carry this stream as some students not here. Let's send this stream here. All right. So that's stream. All right. And of course, let's say Tara not here and so on. So let's see if we can stream this to her as well while we speak. All right, we're sending it in the group so she can follow the stream link. All right. So guys, so do you have any questions about what we just did? Do you understand? Are you even there?
Yes, sir, I understand.
Oh, so like you're coming from far, Chanel. Be careful. That must be near to the class, near to the screen. In fact, put away every distraction you have. All right. Shanta, are you there?
Yes, sir.
Okay, it's lovely. Leandra?
Yes, sir.
Oh, is he coming from far?
No, I'm not.
Yes, hear the background. Background sound big, you know, like a run on a whole heap of space and come say, yes, sir. Know them thing there, man. See what's going on. All right. Michaela, are you there?
Yes, sir.
Oh, all right, you're so near. All right. Casey.
Sir, I'm here.
Oh, yeah. Most likely you'll be there. Yeah, that's a pattern I'm seeing from you. Odell?
Yes, sir.
Oh, good. Good response there. All right, good. Daniel?
I'm here, sir.
Okay, lovely. All right. See what I'm going now. I think Lamar should be there. Or is she?
I'm here, sir.
Oh, okay. So what's happening? All right. Gabby?
Yes, sir.
Okay, good. Yeah, sound loud and strong. That's lovely. Grace?
Yes, sir.
Oh, yeah. Loud and clear, man. Lovely. All right. See if me leave out anybody. Everybody should be accounted for. Deborah.
Yes, sir.
All right. Good. So I'm a bit sleepy though. Are you in a bed? Careful, you know.
No, I'm sick.
Oh, you're sick. Oh, careful. You know, get the vaccine yet. That's why. All right. Well, all right, guys. So this now, the next step is for us to, the next step is for us to say where they will ask you to write an equation. Right now, if they ask you to write what they call an ionic equation, because if what happens now is that the current passes through the compound, right, and then now the ions will be separated, but the ions will eventually form the element. All right. So in other words, something happens at the anode and something happens at the cathode when it reaches there. All right, it's coming like this. I mean, so we're talking about the analogy with the door, right? So let's say it's let's say you're getting some card or something, like a TRN number or something like that. Or yeah, and let's say it's a passport or your visa that you're going to collect then. And then of course the door only hold one person at a time. So then call your name and then supposed to get through. No, at the door nowadays, them do something to you before you can go in. What is that?
Sir, sanitize you.
Very good, Shanta. You're on the ball here. Sanitize. All right. So, yeah. So what happens here is that when the ions reach the anode now, they have to be in that case, coming like them have to get sanitized, but not just sanitized. They collect or give up electrons. All right, they collect or give up electrons. So that's what happens here. So fine, the compound is there, and then the electricity is forcing them apart, and then when it reaches the door, it say, all right, you know what? May I come out of this Banya, man. May I just give up whatever. Because the anions were there because what? They gained electrons. But they see that anions that gain electrons, to form the compound. All right, that's why they are an anion. And the cations what had lost electrons to be in the compound. But now that it is being separated now, you have to reverse now. You have to get back where you have to get back what you had before. So in the case of the anion now would have gained an electron. So let's say we had sodium, and so this is sodium. So remember that compound. Let me just give it the trend here. So it's from compound electrolysis. All right. Ions. All right. Now the ions there now would then be, and we're not gonna give some names to this that CXC would want it to know. All right. Ions would gain electrons, and of course, and some ions will lose electrons. And why this has to happen is that, again, if an anion is in the compound, the anion would have to give up back the electrons that it had. Remember, the compound is so like like we don't remember we have ionic compound here. We start out with the ionic compound here. All right, so it's like coming in, one had to gain. All right, so let's say it lost. So one of them lose, and then the other one gain. All right, I'll show you this now. So the one that gained the electrons in the ionic compound would have been the anion. And that's why I get a negative charge, because electrons are negative. And if you gain electrons, you will have negative charge. All right. Then we have the cations now that, again, had lost electrons and to form that ionic compound. All right, everybody understand what's happening so far, guys? Hope you understand, Even the story here now. Example of this happening, guys, is the sodium, the bonding between sodium and chlorine. So remember that sodium is a metal, so sodium would have lost the electron. All right, and then of course chlorine would have lost the electron. Now remember that if these two combine, you get an ionic compound. All right. And then of course, when it goes through electrolysis now, all of that mash up now, and that under pressure now. So electrolysis is like and it's a two-stage thing, right? One is the current coming in to separate, and the other now is the ions giving back or taking back what they had given into the relationship in the first place. So it's almost coming like a divorce. Actually, it's a divorce. So when people separate now and divorce, don't there's some sharing of things, some giving back or something. Don't that happen, buddy?
Yes,
Yeah.
sir. 50-50.
Yes, sir.
Yeah, 50-50. Yeah. So yeah, fair. So if the sodium they give up an electron in the relationship, and then to satisfy chlorine, who took that electron now, then they reach an agreement here and say, well, if I go separate, make you just cut the losses then. So you get back where you have. And then in that case, there is really no loss. It's a perfect solution. You just give me back where me they give you and we'll move on. So what's happening here now? After electrolysis now, the ions that are formed now will form this. Na come off. Na solid. That's what it came in with to form the and so that's a cycle here. The sodium, again, That's an electron. So you see now that when it reaches here now, it's gonna gain the electron. And then of course to form the ionic bond, it would have to lose it. So you see the cycle now, guys, sodium ion there. Again, the sodium would have had to lose the electron to form the ion. But then if it's going to go back to where it was, it have to get back that electron that it gave away. And so that's what electrolysis is all about. And I think that's what cause students a lot of problems here, because they don't understand this process. But it's a simple process. It's quite logical, guys. All right. Just giving back what you already, you're giving back what you got. But that was not yours, really. All right. So of course, we wanna say that some loss will take place here. We can see that.
Sir,
Yes, go ahead.
so you remembered when you showed us a label diagram representing the the cell, sir?
Mm-hmm.
Electrolysis cell.
Yeah, electrolytic cell,
So
right?
basically that you explained the part where did I say where the how to explain this now? So where did I say boost for the plus the like when it go down in the water something it will go be negative and boost for negative or positive.
Yeah, man. Something along that line, DSNL. So it's something along that line. But yeah, you're right. The only thing we need to add to this diagram now is to say which electrode this takes place. Let's get this out of the picture here. All right, so this is the ionic compound. So we start there. Sodium would have had to give up an electron, and then chlorine would have to gain that electron that sodium give up. So all right, so that's the bond. All right, no electrolysis say, oh, nothing, separate now. And then electrolysis represents like things in life, rough times and so on, everything that can be thrown at you. So it could even be a torture chamber or something, whole heap of temptation. But at the end of it, no, the people didn't survive the temptation, and then so they're giving the separating here. So gain is all right. So sodium now would a gain back. So it's like in CXC now, they'll ask you for the equation. It would ask you, how does Na plus move to becoming and Na solid? And then so this is a natural state, by the way. When you say Na with the S there, it's saying that all right, this is actually the natural state, because we know that sodium is a metal and metals are mostly solid. So this is natural. All right, this is the natural state. Let's forget about the natural thing. In fact, we just want to focus on the equation itself. All right. So do we understand that when sodium is liberated, all right, when sodium is liberated, this is what it will be, a solid substance. All right. Remember, guys, in the compound, because it gave up an electron, its property changed now. So sodium metal in real life would look like a metal. Let's see how that would look like. Sodium metal. And I wanted to get a visual understanding in your head. Sodium metal bonding with chlorine changes both of them. They don't look, the bond they don't look nothing like what they were originally. So let's see how these changes take place. Now this will help you to understand now in real life how, like what you expect to know what will be formed. This is sodium metal here, guys. Sodium metal here. I think I should make it bigger though. All right, let's use this image here. And I'll show you. I think we have some at school. So this is what sodium metal looks like, guys. A piece, just a metal, but it's a very soft metal that you can use a knife. In fact, this looks like a scalpel blade. Like they used to cut there. This is actually real sodium metal. So this is what sodium metal is. Nobody would know that unless you saw it. So and in chemistry we write that as NaS, and the S represents solid form. This is actually solid. All right, so and then let's put our Na there. All right, any questions here? And
No, sir.
all right, let's look at the chlorine gas now. What chlorine gas look like, so that if we did electrolysis, we could be able to predict or at least know what was happening. So chlorine gas now is something, in fact, a dangerous gas that they used to, as a weapon in World War I. All right, but anyway, let's go get this image here, and this is what it looks like. Let's probably tone it down a bit here. That's chlorine gas, guys. This is real chlorine gas.
Yellow pink gas, sir.
Right. All right. So, and it's written as Cl2 in chemistry with the G there. Show that it's gas. Chlorine gas is actually a combination of chlorine molecules, and we know that molecules are covalent bonding atoms. So, so this is what will be formed. All right. So, let's get back to this then. Seeing that we know that this is what will be given off. Let's apply the chemistry to it. How does Na plus become Na solid, and how does Cl minus become Cl2 gas? Now, if you can answer this question, then you should have any problem with any past paper question for CXE, because you just apply the same principle to other things. All right, so we have to write in the equation what happened. Now, let's see, with your knowledge now, if you left class today, which again, class is pretty much over, but if you left class today with just this information and you took up a past paper question that with electrolysis, and they asked you to write the equation, and you wrote what you have on the screen right here now, this part, you'd actually get a mark for that. But then it usually value 2 marks. So you'd have to find out what's the missing pieces. And actually it's there on the board. So it's there on the board. So think about that now. The cation lost an electron. In fact, so the cation had lost an electron, or we could say sodium had lost an electron in the first place. All right, so sodium lost electron. All right, and of course chlorine gained the electron. Now, and we have a situation here now. Chlorine gained the electron, and let's follow this process now. Notice that for electrons we write common letter E with a minus beside it. That's the only thing missing from this thing here. So what do we do with those E's? We just need to tell them which one gain the electron, which one lose the electron. So if sodium had given up an electron, right, in electrolysis, the opposite will happen. So what's the opposite of giving up? Opposite of lose is what? Gaining. Yeah, very good. Gain. So we'll write this as gain, but then it's 1 sodium. So then we're going to write 1 electron. That's it. Right. That's the ionic equation. We're done. We're done with the sodium now. Everybody see that?
Yes, sir.
So it's a story here. This, what they don't show you in most books though, is that before you can reach here now, is that this is the sodium, natural sodium, that they lose the electron now. So it lose the electron, and then now it form this. Now in order to form back this, now you have to give it back what it lost. So that's it. It's just a simple story there. So I just put here Na plus 1 electron, and we'll give you back the sodium. All right, Na plus, listen guys, that's a sodium that lost the electron. Plus 1 electron means that it gave it back. And then that's the story. Okay, so that's it. All right, and then whatever happened to one of them, guys, what's going to happen to the other? The same or the opposite? Well,
The opposite.
The opposite.
of course, the opposite will happen. So if we have plus for the sodium, then we're just going to have minus for this. Minus electron, and you have that. Bam, you're done. Except that it's Cl2, so what we have to go to know? Balance it, no? So if we're going to get 2 chlorine, we're gonna need 2 chloride ion.
The
And
two
also, yeah, and that's it. Done. Full marks that. That's why you write an ionic equation for electrolysis. All right, so we're going to get some more practice with this, guys. So electrolysis is not as hard as over the years students make it out to be. It's just understanding the principle here. All right, this can be done for any ionic compound. And so next class we will we'll talk more about that. All right. And I think one of these Saturdays, one of these lockdown Saturdays, we need to have a marathon. All right. So I'll keep it posted in the group. Yeah, they were saying yes.
Could the marathon be in the evening?
All right, Gabby, could it be in the evening? So good question.
Sir, what is marathon?
Yeah, again, I'll send the date. I'll send the date in the group, right? After contact.
Sir, I definitely have to practice these because they don't stick yet.
Don't stick it. Well, careful, you know, the boards have to get it to stick. If it's this you're talking about, that is. I don't want anything else to stick for you at this moment. All right, but
Sir,
yes,
I'm talking about this.
Oh, you mean the chemistry that's on the screen? No.
Yes.
I want to make it clear. I don't want any ambiguity or misunderstanding. So this must stick in your brain. All right. So, all right, guys, we're going to stop here. And when next time we take up this, we're going to just take up a past paper question and work it right through. Any electrolysis question, we'll just mash it up. All right, get the full marks, move on, and look at some other type of questions here. In fact, what I've also taught you is oxidation and reduction, but I just didn't use the names as yet. But next class, we will talk more about that. All right, so guys, enjoy the rest of your evening. All right, stay safe. All right, and practice your chemistry.
Thank you, sir.
All right, no problem.
Yes,
Hi,
sir.
sir.
Right, sir.